So let's do subtraction of rational functions now. Here I have x plus 7 over x squared plus 13x plus 42 minus 10x over x squared plus 8x plus 7. Like all our other rational functions, we're going to have to factor everything completely first before we even dive into this, before we even mess with the rules with fractions and everything else. So let's factor everything, see if anything cancels. If it does, great. If it doesn't, whatever, doesn't matter. So x plus 7 is in its simplest form. So I have x plus 7. I want to put that over the bottom factors here. It's got to be 7 and 6. So it's x plus 7 and x plus 6. Because 7 times 6 is 42. With 7 plus 6 is 13. Minus 10x is already fully factored for me. The 8 and the 7 here is going to be a 1 and a 7. So I'm going to have x plus 1, x plus 7. Okay, so now I'm fully factored, and I see that I can actually simplify here, but I'm not going to. And the reason why is because when I subtract fractions, I have to have a common denominator. And I see that it already has an x plus 7 and x plus 7 in the denominator, so I don't want to get rid of that because it's already there. If I get rid of it, I have to turn around and put it right back in, and I did an extra step for no reason. So we see that these are in common. What this part is missing is the x minus 6. So I need to get this x minus 6 over here somehow, and this x plus 1 is missing from this part, so I got to get this over here somehow. The way we're going to do that is by multiplying by the number 1, but we're going to set x plus 1 up as the number 1. So what I'm going to do is I want to multiply this side right here by x plus 1 divided by x plus 1. If you divide those out, x plus 1 divided by x plus 1 is just 1. So really, I'm not changing this because I'm multiplying it by 1, but I am going to create a common denominator. I'm going to do the same trick over here with this x plus 6. I want to multiply this with x plus 6 over x plus 6. I think I ran off the board just a little bit. It's okay. From here, we just kind of put everything together. This first term is going to be x plus 1 times x plus 7 minus my second part, 10x times x plus 6, and it's all over your common denominator right there. X plus 1, x plus 7, and x plus 6. Now, I could care less if you multiply out the bottom, you're just adding extra steps where you can possibly make a mistake. This would be a cubic on the bottom, and that's going to have some parallels with you guys foiling it or doing the box method. But I do want you to clean the top up. Don't leave it like this. So we're going to have to FOIL the first term here. X plus 1 times x plus 7 is going to give me x squared plus 8, x plus 7. I want to distribute, play hippity-hoppity, distribute a property. Negative 10x times x is negative 10x squared, and negative 10x times 6 is a negative 60x. My denominator stays the same. X plus 1, x plus 7, x plus 6. All right. Now, combine like terms. I'm going to get a negative 9x squared. That takes care of these. I have a negative 52x. That takes care of these. Plus 7, all over the same denominator, which is x plus 1, x plus 7, and x plus 6. Okay, so there's my final answer. Whew! Isn't that beautiful? Now, we still need to write the domain of this. So I can actually just look at my finished product of my denominator, and I can see that this can't be negative 1, negative 7, or negative 6, because that would make the denominator 0. So then I just simply write my domain is the set of all x's such that x is an element of the real numbers, and x cannot equal the numbers I just stated off, which is going to be negative 7, negative 6, and negative 1. And you're done. Hi, I'm Mr. Buzzard, and I'm making these videos as supplemental instruction for my students. If you found these videos actually informative or they answer the question you're looking for, make sure you hit the like button, and then don't forget to subscribe and then click the bell to receive notifications for future instructional math videos.